Mario will show how Quantargo Workspace can be used to seamlessly turn this model into a powerful API. In the second part, Mario will introduce the 30-day sustainability data challenge, which asks participants to post interesting visualization covering sustainability on Twitter. With the new features of the Quantargo Workspace, we show how to create a Twitter bot, which posts visualization and memes on a daily basis. Mario, you got the floor, and thank you for your time.
So, hello, good morning on this Monday morning. I'm happy to present now the 3 topics mentioned, as Alexander also already said, and I'm really happy to be here also for the, I think, 4th time at the Data Science Conference and the 2nd time for the Data Science Conference Austria. Happy to get this started, and I hope maybe you learned something new today and see what else you could do with R and data science. So as Alexander mentioned, we have a few hands-on tutorials today. I have flipped a bit now the contents, but it's still the same. Just if you want to participate with this tutorial, just make sure, of course, have a computer and or some device, internet connection, the modern browser. And for today, we would also need, we will also code in R and R Studio. So maybe if you have installed this locally, it would be great. And optionally, maybe a GitHub account or a Twitter account would be helpful. Twitter, of course, if you want to create some Twitter bot or tweet via the Twitter API. So the agenda for today, I have to admit, I switched it. So I will start with the Quantargo Workspace introduction, just a quick one, just for you to know what Quantargo Workspace is, what you can use it for, and why it's so cool. And I flipped now just the topics. So we'll start with the 30-day sustainability data challenge. I will introduce the challenge to you and show you how you can create Twitter messages through R. And thanks to scheduling features we've now introduced, you can also just create something like a Twitter bot, which tweets on a regular basis some images or content you want to share. And of course, those bots will be centered around the sustainability topics. So we will create some bot which ranks countries by CO2 emissions and just tweets about the visualizations and the messages there. And the second part is we try to find undervalued Airbnb apartments in Vienna. So as I heard, Alexander, they are staying at some Airbnb apartment in Vienna. And the question is it really cheap? So how could you determine if some apartment is cheap or not? And so what we're doing is we're using some open data set from inside BNB. We train some XGBoost model with tidymodels. And then we also try to forecast the price and determine what's the discount on the official price. And so to say, determine if some apartment might be undervalued or underpriced. And of course, that might be a cheap catch and might be interesting to have as an apartment. And the cool thing about Quantargo Workspace is also you can easily turn your models and your results into an API. So everything you have online is then also accessible through an API and can be integrated in some application. And fourth, we will also have some general Q&A. If you have some general topics, maybe not exactly related to the topics I've just mentioned, you can also just ask right away. And also for the tutorial, just raise your hand or put your questions into the chat. And from time to time, I will then try to catch this and talk about this. So first of all, I start with the introduction of the Quantargo Workspace, which makes it really easy to turn your data science results into an API. So this is something data scientists currently struggle with a lot, and we want to make this very easy. So everything you see in the user interface can also be accessed through an API. So you can easily automate then your models or integrate them into some web application. So it basically supports both the web frontend, which you see in a minute, and also everything is accessible through a REST API. And so the workspace consists of course, the code, the runtime, some packages, and objects like models, which you can then access through those interfaces. And it also supports R, it supports R Markdown. We've now also support for Python, so you can try many different things. Everything which is possible in data science should also be possible there, but it's then also easily accessible and shareable with your colleagues. So you could also think of something like a Google Docs for data science. And we also have a few community workspaces, which I will also then show in a minute. And also what I wanted to mention here is it's now released. So the official release is now quite scheduled with the start of the conference. So if you send us an email to courses@quantargo.com with the subject line DSC Austria 2021, you get a 3-month developer account, so you can also access the paid product and try it out for 3 months for free. So this is the workspace, and I will now like to show you a few nice features about it. So first of all, I'm hitting now the Qubits landing page. I also posted through the, wait a second, through the chat, which I don't find currently. I will paste it later, but it's simply quantargo.com/qubits. So this is the landing page. So everything which I've just mentioned is also there. And it's just super easy to create a new data science workspace. So you can just hit here, create workspace. We have lots of different templates available. So it's either simply an R script, or it could be a Ggplot, a leaflet plot. We've also now added all those Twitter templates, but I will now start with an R Markdown document, which is really nice to create data science reports. So you see it just starts up quickly. Now the whole workspace needs to be created. So this needs to be done just once when it is created. So it's now just starting up. And you see here, this is a typical R Markdown document. So you have here some YAML header to define the title, the output. We've also included here parameters, so you can also parameterize the report. And you can then easily also just create any kind of chunks here. And if I hit render here, you see that in the console, it starts getting rendered. So now the report is just being generated. And you immediately see here also the output of the report. It's just for our Markdown, it's just a bit more convenient to switch to the viewer. So in the viewer, you see it in the full screen. And this is great. So with our Markdown, so the cool thing about our Markdown is you can mix up documentation with code. So this is also called literate programming, goes back even to Donald Knuth, and it's really nice to create reports, research reports, and so on. So you can also, and the nice thing is here, you can easily switch the output here. So we're just here generating an HTML document, but you can also easily switch here to a PDF document, hit render, it gets rendered in the console, and you immediately see the PDF document here. So it's really also easy to switch based on the same R Markdown document, the different output formats. We're also quite proud that we also understand now all the Microsoft related documents. You can also even create here Word documents if you want, or PowerPoint presentations. So everything here is just quite easy and quite fast to set up. So so the PowerPoint presentation was missed somewhere, but here it is. So you can also create some PowerPoint presentation here. So this is quite nice and allows you to iterate quickly and create new workspaces quickly. But what I actually want to show you is how you can create some kind of, maybe more interesting report. So I'm now switching again back to PDF document because it's just so popular. And I would like to introduce a very nice data set I've just come around from, which is available here. So this is a data set from Robbie Andrew. So he's a climate researcher, I think at some institute in Norway. So it's the Center of International Climate Research in Norway. And they have a really nice data set, which has lots of details for each and every country. How much CO2 emissions does each and every industry produce? It goes back even to the 18th century. So it's a really nice data set to work with. And he has this data set for fossil fuels. So, and it's also normalized per capita if you want that. So I've used just this data set here, this kind of CO2, this data set in the CSV format. So what I can do now is I just downloaded the data set. So from the link before, and what I can do now is I just add the data set as a new file here to our workspace. For some reason, this doesn't really work here. Just a second. Just a second here. I try to target content. Workshops. This one. Yes, so I just upload the file here. For some reason, I think it has to do with the screen sharing settings. The drag and drop didn't work. And I just use here, we also have all the packages, all the R packages preloaded. So you can easily, or pre-cached, so you can easily also install the R package of your choice. So I'm using here the tidyverse package, for example, for all the Ggplot and dplyr functionality. Yes, the slides are also available. I just post it in a minute. And also the scales package, I can also add here. Okay, so first of all, we start by loading the dataset, the CO2 dataset in here. So this is just here the CO2 all dataset. And I just try here to, and I just also output it here, can run the chunk. And you see here, the data set we're talking about here is contains for each and every country and each and every year, the CO2 emissions for each for a bunch of different industries. So for coal, oil, gas, cement, flaring, and others. And you also have this kind of data on a per capita basis. And now, for example, it would be interesting for us to see, or for me at least, to see how this, so we're using now the tidyverse package, and we would like to see how this, how this looks like in Austria. So if the country equals to Austria, it would be interesting to see how this looks like. So of course I forgot the quotes here. It's Monday morning, so okay, so I've now just filtered the data set by Austria. And what we would like to show is now some plot which shows maybe something like a bar chart, which shows the proportions of each of the contributions of each industry over time. So I'm now just changing, or a very common approach in Ggplot is to make this possible, change the data set in some way to have it normalized. So ideally, we would like to have not such kind of broad data set. We would like to narrow it down a bit so that each industry can be easily plotted. So one thing is, what we would like to do is we don't need all of the columns here. So we would like to select here only from the column coal until the column other. So this kind of range here. So we're doing the selection based on this kind of range indicator here. And we should see that now the data set is now more condensed. Of course, we forgot the year. So the year we should also include here. Then we should see for this country, for Austria, just the year and all of the industries. And now we would like to normalize it, or we would like to pivot it a bit so that it has a longer format. So we're using pivot longer. And we use year here as an ID variable, but we would like to make this data set now longer so that it can be easily plotted through Ggplot. And you see here, it's now just lots of NAs for all of the old years, but of course for the 19th century, we already have some values for the industries. So of course, the 19th century coal was here a bit bigger. Okay, and now we put this into a Ggplot. So we're creating some Ggplot, which actually bar plot, where we use on the x-axis we use the year, and on the y-axis we use a value, and we fill by the name of the industry. So we just now want to create a plot out of it. And this looks already quite nice. So we see here over time the contributions of each and every industry in Austria. Of course, you don't really see it. So I'm just adding here some title with GG title. I have something like CO2 emissions in Austria based on industry. Okay, so now we also have a nice title and know what this plot is all about. Of course, it's not GG, so it's GG title, like this. And you see here now, now we have the CO2 emissions in Austria based on the industry. So also with a nice title attached. So you see, it's a very nice data set. It ranges back to the 19th century. And you see that coal was huge in Austria around 1900, beginning of the 20th century. Then it dropped off sharply, pretty sure because of World War II or I in this case. And then it, increased again. And now we see that we again have very high levels, but oil is now the main contributor in Austria regarding CO2 emissions, as compared to coal is now diminishing even more. So this is just a nice plot or a nice visualization we can do here with our Ggplot, and in this case also a Markdown. So since this is now in our Markdown document, we can even create some nice text around it. So we have some title, for example, CO2 emissions in Austria, or CO2 emissions by industry. And we can add some description, everything you can think of. So Ggplot shows the CO2 emissions in Austria by industry. Okay. And if we render this, now this plot gets included into the PDF document, and you already have a nice report. I also show this in the viewer. So you already see here everything here. So with a nice plot and everything here. Maybe you don't want to include so if it's more like for a manager, the report, you might not want to include the source code here. So you could also use here the chunk option echo equals false, which would then remove the source code from the report. And the report now looks like this. So you see it's all quite quick. Maybe also the warnings we don't want to have here. So warning. Warning. False. Yes, and now we have a nice report created here. This again, we call, maybe we also change the title here, and we're all done. So this is a nice feature you have with a Markdown. And now the question is, what if we don't want to have this report only based on Austria? So of course, Austria is a great country. The conference is called Data Science Conference Austria. But the question is actually, how can we parameterize this report and use it just for another country? So for example, how could we create this report for Germany, for example? So in this case, we need to replace, so to say, every hard-coded mention of Austria with another country like Germany, for example, or Serbia. And so the question is here, those kinds of parameters come into play. Those work exactly the same like in our studio. So for example, you can have a parameter called country, and this parameter has just the value Germany, for example. And now the question is, how could we reuse this parameter? So first of all, we can reuse it because it introduces a new params object, a list object in R. And if we then access params country, we just get the country which is set. In this case, it would be Germany. And so let's see how this looks like. So we see here the data is now different. So it's actually now the data from Germany. In Germany, the situation is a bit different. They had lots of coal, and the coal is now decreasing a lot and actually decreasing more and more. In Austria, it's not such a clear decreasing trend since 2000. But now the question is, okay, now we want to also replace all the other mentions of Austria with Germany, with our new parameter. And you can do this, for example, here in the title, you would need to, so I'm using here some placeholder and the function as printf. to just include the parameter country in the title. And what you can also do is you can also in the text replace the text, some text parts of the text with parameters or R code. So in this case, you can do some with those upticks. You can easily integrate here some params country, some variable inside the text. So let's see how this looks like. It's called params, I'm sorry, not param. Okay, so now you see here a very nice report which shows the CO2 emissions by industry, and you see also the text here has been replaced with the parameter we just set. So now we can create a report based on this parameter. So if you want to change this to China, you have a report on China, for example. Yes, so you see here the numbers in China are just increasing. Especially coal is here, the main contributor here. If you want to have the same thing for, I don't know, Serbia, you can just also render this and see how this thing looks like in Serbia. So in Serbia, we don't see a clear trend here, and coal is the main contributor here regarding CO2 emissions. Okay, so this is just quite a nice feature of Markdown, and most of the things are already included in our Markdown. It's just with Quantargo Workspace, you can easily work online. You can also publish it. So you can, for example, also publish the report so that it is accessible to others. So the whole thing is then also available for your colleagues through some link. And of course, you can also share the whole thing, so you can invite others to work on the workspace or to also edit the workspace. So this is quite a nice collaboration feature, I think, which you can use here. In any case, I just looking at, for some reason my Zoom gets away from time to time. Here it is. So what I'm doing is so for this presentation, I will now share the link. So the nice thing is everything I'm doing here is just shareable, and I'm now just sharing the link of the report I just created, also the link of the data set, but I think I also include maybe the link here by industry. The data is from this. Okay. So again, you can already get started here for free. So everything, if you want to have a public workspace, it's all for free. If you want to have a private workspace, then you can check out the paid plans, or with the code I just mentioned here, and which I also post here. You can also just check. You can also just get a free, until the end of the year, a free developer account if you send DSC Austria 2021 to this email address, courses@quantargo.com. Okay, so this was the first just a little show off of the Quantargo Workspace, what it can do. And but this is not all. So we said, okay, you can share, you can publish, you can invite other people. You can also let other people view only the output of your report. Just if you want to. So one very common case, if you want to share the report on Twitter, for example, you can do that. You just need to paste the link to some social media account and you immediately see the nice picture of it and it's everything reproducible. And by reproducible, which is very important in science and which is also what I want to stress here, all of the packages which are used here are installed with a specific version number, most typically the most recent one from CRAN. You can also install GitHub packages, for example. But the nice thing here is you can also, if you want, download everything. So you can export the workspace you want to work on locally. So this just downloads the whole thing as a zip file, and you just can then work locally on your thing. So if you see this here, this is just the zip file, and you can then just open up the RStudio project and you just work on your workspace as you did online. So this makes it really easy to work online as well as offline with your data. Okay. So another thing which I would like to introduce, if there are not more questions so far. Yeah, the other thing is I will share the slides here. To anyone? So I also share the slides here in the chat, so you can just follow also in the chat here. Okay, so what I would also like to introduce is the 30-day sustainability data challenge. So this is something I just came up the last days, and what I wanted to ask you is if you are being creative or if you have a nice data set or visualization you would like to share, it would be great if you just post something on Twitter and include the hashtag 30-day sustainability data challenge. So this challenge goes on for 30 days and it's all about sustainability. So just include the topic, some sustainability topic, and ideally also include the source code or something, or the source how you created your visualization or your thing. So it's all about open source, and we would like to also share new data sets and also techniques maybe you used for some visualizations. So I also included here a few visualizations here. I also post this to the chat here. And so I would ask you to, if you want to just post something, there are prizes to win. So we will in the end calculate all which user gained the most, of course, except for us, but which user gained the most likes or retweets. So it's highly encouraged to, you can also just retweet stuff if you have the source, of course, but it would be interesting to have more, more interesting ideas about sustainability and data through this challenge. And there's also nice prizes to win. So the first one gets a goodie bag and a 1-year subscription to the courses. So for this, if you're interested, please participate, post something nice, and for sure, there's something to win and nothing to lose. So I would like to ask you to start with this. Why this challenge is a bit different now is because it's also clearly allowed to use something called a Twitter bot for this. So since we're calculating or we are just aggregating, summing all the likes and retweets of your tweets of your user who participated, it's also encouraged that you just create some kind of Twitter bot, which is basically just some program or some R script, which publishes new insights maybe on a regular basis, for example, on a daily basis. And by just tweeting on this regular basis, maybe you get more likes and retweets, and you don't have to tweet every day, of course. So this might also be interesting for you for other in other use cases. And what I would like to show you here is just quite a nice Twitter bot we created. So we have the link here. I also posted here to the chat. And this is actually not a very intelligent bot, but I just want to introduce how it works. So just before the conference, we came up with a few different ideas. So this kind of Twitter bot is basically showing you the countdown of the challenge. So, so the idea here is that based on the date, so the end date of the challenge is October 27. And what it does is it's calculating the countdown. So how many days do you have left for the challenge? And this is basically just creating some text. So if the countdown is greater than 30, then the challenge hasn't started yet. Now it has been started. So now if the countdown is exactly 30, then it's starting today. And if it's smaller than 30, then there's only, you know, some days left. And else the challenge has already ended if it's less than 0. So this is actually how the text is generated. Very simple, just showing you the countdown here. And we're also using here 2 packages, which I would like to introduce: the meme package and the R-tweet package. So the meme package is actually something to create such nice memes like this. So, you know, just a background image and a nice with a message. This meme package also puts it into the right format so that it's easily shareable through social media. And so here you see in the code that this image here is being created. So on the upper side, you see the hashtag 30-day sustainability challenge text. And on the lower end, you see exactly this text I mentioned before, how many days are left for the challenge. And this meme is then saved as a JPEG. And here comes now the interesting part. Now we just created some text and an image, and now we would like to post it on Twitter. And how we can do this is basically, so here it's actually now the, here I already encountered an error in our bot. So this is actually why the text is still not updated. But what I wanted to mention here is for just to create some kind of bot for Twitter, you actually need not only a Twitter account, but also a developer tokens to interact with the API. So what we've done here is if you have a Twitter account, of course, you can go to developer.twitter.com. And here in the portal, you can then easily create a new app. So I created here an app called Quantargo Bot. I also created others for the sustainability challenge. And here you can then create a new app. This just gets checked, but it just takes a few minutes to set up. And what you need here in the end is the keys and the tokens for your bot, for the program you want to create here. So you need the API key and secret, and you need the access token and secret. And those secrets can then be integrated into your R script. So they get integrated through environment variables. and you can set the secrets here in this kind of secrets pane. So you see here all of the different secrets you can set here. I cannot change them because I'm not the owner. It has been created by our system user. But here you can then easily set the secrets. Those are encrypted in our system and only available to you. So it's really secured in transit and addressed. So we don't store anything in, so everything is encrypted in this case. That's also why we trust, why we are so open with everything, because it's really very safe on the application level. And those secrets can then be accessed here through environment variables and can then just create those kinds of Twitter tokens, which are then used to post a tweet. So this is actually how it's all set up. So this is how it's communicating with the API. And this is not everything. So we have created those secrets, which are then used by our Twitter bot. The other thing is we also have it scheduled. So one thing is, of course, to have this Twitter so that it just tweets something once, but it's actually very powerful if it does it on a regular basis. So for example, on a daily basis. And that's where the schedules here come into play. And this is actually what we want to do now. So what I want to do now is, based on this kind of template, I would like to create a new Twitter bot, which basically tweets the thing we just created before. So instead of this kind of our Markdown document we had before, we would now like to create the same thing on Twitter on a regular basis. Okay, so let's get started. The nice thing here is if you have a nice template here, you can just copy it here. And what I want to have is for example, sustainability challenge CO2 bot. So I just copy the workspace, which you're seeing here as my own, so that I can easily edit it and add my own credentials and see how it works. So what we see here is exactly the same thing. The only thing is here now the secrets are now not set. So now all the secrets which are used here are now not set, and I need to set them again. But this is just an issue I will handle in a minute. The main thing here is we would now like to create the same thing as we did before in this kind of R Markdown document. We would like to transfer now to Twitter. So instead of this kind of meme bot, I would now like to also put the data set here. So I would now also like to include the file I just mentioned before, the CSV file, which contains all this CO2 emissions data. And I would also like to, based on exactly the same code here, I would also like to create a nice plot here. So this plot now says something. So of course, now the params is not available here. I can set the params also like this, like country equals Austria. I also need to, for this workspace now, need to install the tidyverse package again. So this is also quite quick. So it should be. Okay. Okay, for some reason that didn't work. Try again. Okay, now it's here. So now we have the tidyverse package here. We now try to create exactly the same plot as before. Okay, so now we see that it's creating exactly the same plot here. And the other thing is what we're missing here is we would now need to save this plot as a file just to share it, to make it shareable on Twitter. So in this case, we can use the ggsave function to save it as a new file like co2.jpg. Okay. So this just saved this previous plot as this JPEG file. Okay, so this is one thing. So now we have a nice plot. And the other thing is what we would now like to do is we would like to add some kind of text to it. So of course, there are many different possibilities here. What I decided here is, and I just paste this over. What I decided is I would like to add some text here, which basically repeats the proportions of the CO2 emission level for each country, just in a table-like fashion. Table, whatever is possible in Twitter. So this then looks like, so not country cell, of course. So this is now called params country. Message list. We also need the scales package just for the percentage function. Okay, so now it's creating here this nice message list. So you see here, this is actually what our bot will be tweeting finally. Maybe we also add a new message here. So this is now just saying, okay, in Austria, oil is the main contributor, even more than half is contributed by oil, traffic. And now we just put this into the final message. So if you tweet something, if you want to participate with the challenge, just make sure that to include also the hashtag 30-day sustainability data challenge, also the rstats hashtag and the sustainability hashtag. So just to make sure that you maybe gain more followers or more people see what you're actually doing. So let's see how this looks like. So again, it's not country cell, but params country. I'm just changing this. Okay, and this is now our final message we want to tweet. So basically what you just have imagined, you see this picture, which is included in the tweet. And then you see the text, share of CO2 emissions in Austria in 2019. Okay. So this is now basically everything we need for our Twitter bot. And what we're doing now is, so we don't need this anymore. So we are basically, again, creating the token. I need to include now then the credentials again. And then we are posting the tweet. And the tweet then includes basically the message. So the message is also called the status here. And of course the media, and the media here is now, the media is basically just the image we created before. So just this kind of JPEG image we created, we're including here. Okay. And now everything is set except for the credentials. Just one more thing maybe, or let's try this out. We need to set the secrets now. So as I mentioned, you need to go to this kind of Twitter developer platform, get the credentials I just mentioned, and I'm now just including the credentials for our 30-day sustainability data account. It's not for the Quantargo account. So I just want to tweet now with our sustainer from this account here. Okay. So I'm now just entering the credentials, which just a sec. Since I'm sharing the screen, this was not such a good idea. Okay, we need to have this also set here. Again, what I'm doing here is now I just want to, since I'm sharing the screen, I don't want to have you see the credentials, but the thing is they're in any case stored then in our system here. So I'm entering now the API key. I'm entering the API secret. I'm entering the access token. And I'm entering the token secret. So this one. So the access secret. So everything is now set up and we can just have a try now. Of course, we also, so everything is then encrypted in the database and we're using from AWS, the service KMS here. And also if you want to get out the credentials, it's not possible. So it's all then masked. So what we're doing here is now we want to, for the country Austria, we want to create our first tweet. Let's see if this works. And it did something. Let's go to Twitter. And I'm just hitting refresh now. Huh, and it worked. So this was now our first tweet. So it's showing the share of CO2 emissions in Austria in 2019. So we see here oil is the main contributor here. And of course, gas, coal, and so on. All the others are just below. So oil and gas and coal are the main contributors regarding CO2 emissions. And also, of course, we hope to come down with those numbers and to be hopefully CO2 neutral in the end. So that will be the challenge of the next generation, of our generation. And the only thing is for the Twitter bot, which is kind of annoying, we don't want to post the numbers from Austria all the time because that gets boring and nobody cares. I would like to do it now on a more random basis. So we would like to, so of course, Austria is not the only country which is included in the data set. And so if you're checking here for other countries, like using here the unique CO2 all, it's uppercase countries, so R is picky about the this. So we see here actually the dataset contains 226 countries. Actually not so many, because global and international transport is actually not a country, but anyways. But here we have basically all the countries in the world. And what we're doing now is, instead of using country equals Austria, we would like to now use from this kind of list of all countries, we just sample some random country out of this. So for example, we can use sample here, take out just one country. Of course, we're not setting here the random number generator because we want to have it truly random. So the next one would be Israel, and then it would be Chad, for example. So this one makes sure that now the country is not fixed to Austria, but it's actually just a random country we are sampling here. So I'm just checking here if this works. So for this, I'm hitting Control Enter or Command Enter for Mac users and just see how this looks like. So for example, this would be the CO2 emissions of Paraguay. And you see that in Paraguay, you have lots of oil and not many other emission types here. So everything is based on oil. And you also see the share here, oil contributes above 95% to the whole emissions here. So maybe this is interesting. And I would like to now have this bot scheduled. And my suggestion would be now, so since we have now this nice scheduling feature, I would like to introduce a new schedule here. So I'm scheduling exactly this file here. I want to have it run at 9 a.m. So Vienna time in this case. I want to have it daily, and I want to have it run every day. This auto-publishing feature I don't need for now, but I would now like to save this kind of schedule. Maybe we set it to 10. Maybe we set it to 10:30, then we can even within the session check if it did something. So this is our first schedule, just at 10:30. So this runs in just half an hour. And the other schedule, we can also just enable, I want to have it run at, I don't know, 6 p.m. Vienna time. And I also want to have it run every day. So this is just our second schedule we would like to introduce here. So now this bot will tweet twice, so two tweets daily, and it will just randomly sample one country and post what's the share of CO2 emissions in this particular country, and also show the chart. So again, I hit again once run just to see how it looks like. Okay, this is a bad example. Wildfires, okay, this is just randomly sampled. But here we see it for South Korea. Again, in South Korea, it's getting up. And coal is contributing more and more to the whole CO2 emissions here. And this is not only now posted within the Quantargo Workspace, but it's now also available within our Twitter account. So you see here that we have just tweeted the thing in Kuwait, which was a bit unfortunate. didn't anticipate that. We should have filtered the countries before. And also we see it here in South Korea. Also, we see his problems with spaces here for the hashtags. Anyways, but we see the whole thing's work. The whole thing works, and it's now tweeting twice a day about the CO2 emission shares in each country. I hope you liked it. Again, everything here I just used here is also for free. You can also download everything locally and work on this locally. And the other way around, you can also work on this locally and then upload it. So we also have a nice deployment feature. We will also then integrate the whole feature for GitHub so that you can easily link your GitHub account or a GitHub repo to the workspace. If you need more documentation also for, and what I missed. Last but not least, as I said, everything is available also through an API. So the API basically is available here. You have 100 calls a month for free. If you need more, of course, you need. We have other paid plans available. And the idea here is that once you have your API key, you just can copy it to the clipboard and have it run here. And everything we did here before, like generating our Markdown file, even including the parameters and even executing some user-specific code, can be done through the API. So everything you can access here through the user interface, you can also do through the API. And you see here, it then also returns here in this, through this call, the document as we had it before. So you can even automate this and just have it run on your own schedule or introduce your own data sets through the API into some report. So this might be also quite practical if you don't want to run your own R server, and if you want to have, of course, this scheduled on some basis. Okay, so this is it. We also have the documentation here. So all of the features are also documented. Also for the API reference, you can just take a look. And I say thank you for the first part. So this was actually the Quantargo Workspace introduction part, and also creating our first Twitter bot, which will hopefully tweet at 10:30, its first message, its first scheduled message. And I say thank you, of course, for the first part. Please let me know if you have any questions so far. So, of course, if not, or if it was too quick, you can also send me an email, or of course, the recordings will also be available afterwards. So my suggestion would be to then already jump to our next, to the next topic in the tech tutorial. So the next topic would be to find undervalued Airbnb apartments in Vienna. So I met Alexander yesterday, and I think they're staying at some Airbnb apartment, but for sure they don't have an idea if it is really cheap or if it's over or undervalued. Of course, this is all quite so of course this is all quite relative, and I didn't dig into this too far, but I just want to introduce now this kind of use case here, which is actually, I find, one of the most interesting data sets available, because Airbnb has lots of different data. So like reviews, text data, you have geolocations, all this kinds of different data you can actually use and make value out of it. And I think Airbnb does already lots of things with it. So first of all, I would like to introduce the data set we're talking about. So the data set is, I really like to use this, is from inside Airbnb. So inside Airbnb is a website which allows, or from Mary Cox, and Mary Cox was just annoyed that, or was thinking that Airbnb just inflates the rents and that hosts have multiple apartments listed, and that this also increases the rents and makes living space less available. And that's why he began to scrape the data from Airbnb and made it available to data scientists like us. And he was actually, I think, sued by Airbnb, but won. And so this data set is still available, and it's available for many, many countries. So I just post in the link here. And so, for example, we have it here also for Vienna, of course, also for many other different cities, but for the bigger ones, it should be available. And for now, of course, there are many different data sets available. For now, we would like to look into the listings data set. So, it basically includes all the data of the listings, even some data from the host, even some text descriptions. So let's take a look. I will use, for this, I will use RStudio, and maybe this one. And of course, the time is not, we don't have enough time today for, you know, very extensive analyses, but I just want to give you a quick overview how you can tackle this problem in R using tidymodels. So one thing is AirBnB. So our goal is to predict prices of Airbnb apartments, to find undervalued or underpriced, or find cheap apartments city. So the goal is we want to have a model which, based on some features or some attributes of the apartment, determines the price as good as possible. And if this price is not reflected in the actual listing price, then we think that the host has offered this apartment too cheap, and then it's maybe a good value, or it's maybe interesting to stay there. Okay, so first of all, we would like to get the data. So I'm just copying here the link from the listings dataset. So the listings URL is available here. And what I will also make extensive use of the tidyverse packages. So I'm just loading it here, the whole thing. And what I would like to do now is I would like to read this in. Of course, we could download the dataset first if we want, or we can also use the function read CSV. And since this is a gzipped file, it's not only CSV, but it's also gzipped. We can also use the gc file wrapper here to just read in the listings. Okay, but this doesn't work for online files, so still we need to download the file listings URL, and we put it into the, we save it as listings CSV. So this just downloads the listings URL as this file and makes it available here. So it's now been downloaded. And now I can read this in. So this kind of local file, I can read in here and just see here how the listings look like. So listings, just checking the listings here. I see here the whole data set. And you see here that the data consists of listings URLs, so the actual URLs of the listings, the scrape ID, last scraped, the name, so it's all from July. It has a description, it has a neighborhood overview, it has a picture, it has a host ID, a host name, some infos about the host. It has a neighborhood, so the neighborhoods are the districts in Vienna. So Vienna has 23 districts. And so, for example, Donaustadt is the 22nd district, Leopoldstadt is the 2nd. Innere Stadt, for example, would be the 1st. Then we have how many listings does the host have. Then we have some host verifications, lots of different, of course, also some infos about the apartment itself. So how many rooms, how many bathrooms, and most importantly, what's the price? So this is the price here. So this is a very rich data set. And what I also forgot here, very important, is longitude and latitude. So this is the actual location of the apartment. So if you plan to create your own Airbnb listings, just be aware that the data is available, quite easily available, not only to the government, but also to the general public, of course, through data sets like this. The thing here is now what we would like to do is we would like to maybe, so some of the data, so most importantly, we would like to check the price. So the price is our main or most important variable here. Sorry, it's still Monday. Okay, and we see here that the price is actually not really nicely formatted. So actually it's even more expensive here. $9,270. Okay. So this is actually a problem. So we need to convert the price to a numeric variable. So there are two ways to do this. One is you could, of course, just substitute the dollar with nothing. And then, so like this, fixed true, so to make sure that it's really now regular expression. And this just removes now the dollar sign, and the result we can then easily turn into a numeric variable. So this would be one way to tackle this. The other way is to directly within the reading the, by just reading in the CSV file, you can also just specify the column types. So this can be done with the call types here. And if you have, for example, the calls defined as price equals to call number, you can already tell the read CSV function that this column needs to be converted to a price. This is not only more, this is most of the time better or more flexible and also faster, of course. So maybe if this is an issue, it's better to already let the read function know here what the actual type here is. If we just look at the other listings here, we see that we also have numbers like host response rate, host acceptance rate. So all of those kinds of things are probably, since it's including a percentage sign, it's all here. It's all here as formatted as a character, so our model cannot really make sense of this. So in those cases, you would actually need to also tell the read CSV function that, for example, the host acceptance rate is also a call number. And here we can even tell it that the NAs, those NA strings, are formatted like this. So this makes sure that it's really formatted in the right way. Okay, the NAs need to go there. Okay. Okay, so listings, for example, host acceptance rate is now also formatted correctly with NAs and just the numbers. So this is just a nice way to have it already formatted in the right way. And of course, this can go on and on. It's a very big data set here. Okay, so this is the listings data set. Once we are somehow satisfied, we can start with the tidymodels prediction. So we just need here the tidymodels package. And what's important here is all of the time people are confused about cross-validation and how to split the data and when to split it and why it's important. So it's very important to make sure that you don't overfit your data. So I think that many people just don't know that the models we're using here, so today we would like to use the XGBoost model. Those are very powerful models and they pick up any pattern they want and are prone to overfitting. So that's why we make sure from the data side to only evaluate the model on previously unseen data for the model, so that it's not just fitting noise in the end.
Quick question.
Yes.
Where does the calls function come from? Because
sorry,
the
again?
calls COLS function, I can't find it. So from which package does it come?
This should be from the readr package. So readr has the calls function here.
Thank you.
Okay, so this is just all from the readr package. So this is all readr. It's also quite fast. So there are some differences to the read.csv, which is already included in base R, but readr is definitely faster, I think by a factor of 5 to 10 even. So I would honestly actually recommend this function if the CSV files are big. And if this is still a problem, then from data table, there's this fread function, which is actually, I think, the fastest. Okay. In any case, we would now like to start with modeling. And at the very beginning of modeling, you should make sure that you split up your data set into a training and a testing set. And the idea behind it is that no matter what happens, and if you can afford it data-wise, it definitely makes sense to do something like an initial split and split the data into, so the initial split, I think it's 3/4 of the data set is split into a training set and 1/4 into a test set. So the proportion is 3/4. And the idea behind it is that no matter what happens, it's great to have in the back a test set which the model never saw, which even your cross-validation never touched, and which is then your real out-of-sample validation data set, which you should actually just use once, ideally. And so if you make a bigger analysis and want to compare multiple different models, for this kind of final shot, it's great to have a data set available which has not been touched before. That way you make sure that even if you messed up something, you still have this kind of validation in the end. So I would really recommend this. And then you can still split this into a training set. So training, initial split, and train, and a testing set. So you see here that and also the testing set. You see here we have a training set of over 8,000 observations, 8,700 observations, and a testing set of 2,900 observations. So it's about 3/4 training and 1/4 testing. And I would really recommend doing this at the very beginning. Okay, so this is just one part, of course, splitting the data. And as we see then later for training, we will then use something like a cross-validation to make sure the model is nicely evaluated. Okay, then the other part is the recipe. So create a recipe. And the reasoning behind this is that, and this is very cool, and I think especially cool in tidymodels, even if you compare it to scikit, because the recipes also, you can think of the recipe also as a model. So all of the pre-processing you're doing, like the feature engineering you're doing before modeling, is also trained like a model, and they make sure that the pre-processing is not using any information from the test data set. So this is a very important part, because if you think of normalization, or if you, for example, just center data around 0, and you just subtract the mean from it, this mean needs to come only from the training data set and not from the test data set. If you also use the information from the test data set, then you will unfortunately inflate all your performance numbers, and your model is very prone to overfitting. So this is why this kind of recipe approach is quite nice. And so a recipe is created with the function recipe and includes basically the model formulas. So for example, price, which is predicted by other variables. So currently we're not definitely sure which variables to take. There are a few techniques we can use. But for the time being, I will cut this short, copy the results over, and just explain what I did here. Otherwise, it gets a bit too lengthy. But just for you to know, I used a few different techniques here, which is just to, most basically, I used a lasso method or lasso model just to get rid of maybe unnecessary variables and to make sure that only the most important variables are included. So this recipe I also copy over to the chat, of course. Huh. Where is the chat? Ah, here. Okay. So this is the recipe, which I just explain in a minute. So one thing is we want to predict the price, of course, and we are now doing this based on a few different variables. Of course, you can also use more variables. It's just that your model fitting procedure takes a bit longer, and sometimes it's also getting confused with too many variables. So it really makes sense to filter out the variables. So variables have been filtered with lasso. So I just used lasso here, but you can use any other. There are many other different methods just to see which kind of variable makes sense for the model. Also, what I want to stress here is the price. So if we look at the price, then of course, this is just the listing price. And what we're seeing here is that it's highly skewed. So, so this price in a way doesn't really make so much sense to the model. So the problem with very highly skewed data is that the model will overemphasize or overfit on very high prices, where then the error gets very high. So it's actually a good idea to do some kinds of log transformations or to transform the price into some different scale. So for example, if we just log the price here and just check the histogram here, we see that then the price already has some nicer bell-shaped form. So this is typically better for model fitting, because then the model doesn't, it's more focusing maybe on the more average parts and not on the highly, the very high prices, which might produce high errors in the model. So logging of the price is a very good idea, which we also should do. And I'm using here just the mutate function where price equals to log price. I'm doing this here not in a recipe because I ran into some issues when the outcome is changed. This is something I'm not really sure about, and that's why if for transforming the outcome, I typically use it outside of the recipe. There were just some numerical issues when I just checked this. Okay, so now we have the price. Also, the range of the price looks a bit off. So it's -infinite and 9, which is also still quite high. The problems here are twofold. One is the log, since the price seems to be 0, then the log of 0 is infinite, -infinite. So it might be better to have some kind of offset here, just to add 1 to the price, so that if the price is 0, it still gets transformed to 0. And here we see here that now the price is between 0 and 9, so it's now not -infinite anymore. So the offset here is important, the offset +1. This is the case for most price-based columns. Could also be credit balance or something, or income. The other thing is what we need to do here is, it seems to be that this one is really off. So I'm just filtering out here those very outliers where the price is bigger than 1,000, for example. I just want to get rid of this price of 9,000 or something. Yeah. Okay, so this now looks like that. It's strange, to be honest. So this looks fine. And if we filter out the price before, it seems to be a bit off. Maybe it's using the wrong price function. So it's very strange that the price.
Shouldn't you price less than 1,000?
Ah, I'm sorry. Yes, of course. Thank you. Yes, most obvious. Yes, thank you. So this is now the histogram I was more looking for. So it doesn't have those huge outliers. Of course, we can also have the price maybe just above 10 euros or $10 or something, just to make sure that maybe those very cheap listings are not there. But maybe we also take this out. But I just take the very expensive ones out here. Or $10, something like this. Okay. $5. I just want to get rid of the very low prices also. Okay, so now I have the listings here. I have this recipe which I wanted to explain. The thing here is, again, the variables are filtered. And now I made a few observations in the data set. One is, if you look at, now we're only looking at our, so setting the seed here to 42, just to make sure that the splits are all the same all the time. So the observation I made here in the training data set, and this is also true for the entire, I guess, is that if you plot the training data set and you use something like a box plot to plot the neighborhood, I think it's, how's it called? Neighborhood cleansed, I think. And I'm using the neighborhood and the price. Then what we see here, and we don't see it because it's not flipped, so we use chord flip here. So what we see here is that Innere Stadt, so the first district in Vienna, has by far the highest prices. So you see here a clear peak. and the others seem to, you know, vary a bit, the other districts, but the first district clearly stands out here. That's why I've converted the is Innenstadt, just some kind of, I created a new variable which just indicates that this apartment is in the first district. And then I got rid of neighborhood cleansed. The reason here is, since this is like a factor variable, it has, Vienna has 23 districts, and this means that each factor gets converted through dummy encoding to a new variable. So if the factor is included in the model needs to deal with a lot of different variables, and gets confused. And so this is why it makes sense to only have this kind of indicator for the first district and get rid of the others. The other thing is the last review. This is just an indicator how frequent this apartment has been reviewed, or how recent. Here, what's being done is it's converted to a number. So the training data set here has a last review column, and it's actually a date. And the date doesn't make too much sense because it's just a date is just the number of days since 1970. If it's converted just to a using as date. But if you just subtract here the current date, then it's just how many days it's from now, how many days it's, you know, in the past reviewed. And this makes more sense also numerically. The other thing is, which is being done, this is just for XGBoost, it's dummy encoding all of the nominal predictors. So everything which looks like a character factor is here dummy encoded explicitly. This is really necessary for the XGBoost model, as we have experienced. The other thing is then this reviews per month. So here we have the listings and the reviews per month. And here we see that we have some NAs, and those NAs are just then converted to zeros because XGBoost also has a few problems with NAs here. So we just replace here the NAs with zeros. So this is our whole pre-processing. And since we're doing this in a recipe, we make sure that no information from the test data set is introduced in the training data set, in the model training. Okay, so this is the whole pre-processing. And now let's create the model. As you see, a lot of time, actually, even we would need much more time to do this really properly. And the whole data pre-processing steps are the most involving part. So training, not so much. Of course, you can always spend more time here and there, but most of the time well spent, I would say, is here at the feature engineering steps and really making sure the model gets the right data, and that's it. So just to create the model here, we use here the boost tree function. So the boost tree is just a wrapper around all the different boosting tree models, and XGBoost is a boosting tree model. So we're using here the mode regression. And now we can specify also the model parameters, which are available for all of the boosting trees. One parameter is, for example, the mtry parameter, which is telling you at each split how many different variables should it take into account? Sorry? Any questions? And we can use those kinds of placeholders here, tune, which indicate that those kinds of variables we would like to estimate during the tuning procedure. So we would not like to fix it here, but we would like to really find out during tuning which one is the best. You can do this actually with all of the predefined model parameters. Just for this example, we also have the learned rate. So the number of trees is how many trees are being built. And the learn rate is basically how fast does the model converge. So to some local optimum maybe. So this learn rate is here set to 0.01. Of course, you can play around with all of the different parameters. It's just the case that then your parameter set gets bigger and bigger. Okay, so this is just our model specification for now. We're using XGBoost because it's just known that gradient boosting models work very good on those kinds of tabular data sets. So that's why we're just taking the easiest route here. The other thing is now we need to put together the model and the recipe. So the pre-processing and the model are being put into an object called a workflow. So we just build up a workflow here. And to this workflow, we can now add a recipe, which is here called rec in our example. And we can also add here a model, which is here XGmod. It's called XGmod. So this makes sure that during the whole tuning procedure, the workflow applies the pre-processing steps first on the training set, then applies the model fitting procedure, and then just in the end evaluates this model on the unseen testing data set. So this is very important here, to have this specified here as a workflow. The other thing is now the final tuning procedure. So we're using then the workflow, and we're using a grid-based search. Of course, there's also other techniques you can use. But what we're just simply doing is we just iterate over all different parameter combinations and see where the model fits best, basically. And here comes another thing. What we would also like to introduce here during the splitting procedure is actually now a cross-validation data set. So the idea here is now we have just a training and a testing data set. But even within the training data set, we can split this data set into different parts and have it, for example, for a 10-fold cross-validation, have it evaluated on 9 folds and then tested on the other fold, just to make most use of the data. And we can define this using, for example, something like this cross-validation. So there's this V-fold cross-validation, and we just use the data. In our case, it's train and the number of folds, which is, we use here 5 just to make sure that the runtime is not too big. So we call this AirBnB CV. And this data set is then used during the tuning grid function. So it's just iterating over all of these folds and tries to find the best parameter combination here. Okay, the other thing is we define a metric. In our case, we set the metric to, for example, root mean squared error, which is a nice metric just for regression. And then most importantly, we set the grid. So this is now the tuning grid, which we can use. And here we specify the actual number of parameters the model should evaluate during each split, or the tree should evaluate. We're using here 2, 5, 10, whatever. Of course, this grid could be denser. If you have more time and computing time, you can make this grid even bigger. And for trees, I also use, for example, 500, 1000, 2000, I don't know, something like that. So this is now not a very thought through grid, but of course it should work at least. Very important also for tuning is if you can also add here a crossing parameter, sorry, a control parameter, which is just to make sure that you get the text outputs during tuning. So if tuning takes longer, it really makes sure that you also get the output from it. Okay. So some. Okay, so this is here this basic tuning grid function, which uses this cross-validated data set. It uses a root mean squared error for evaluation, and it's using this kind of crossing grid. So it's using this 3x3 tuning grid to evaluate the best model. And for some reason, maybe I'm missing. Okay. Okay, the workflow is not found here. Ggplot not found. Okay, I need to source in this whole thing. The recipe is not found, so I need to source in this whole thing. Let's see. And now it's being processed. So now we're tuning our XGBoost model. This might take some time. Please let me know if you have questions in the meantime. I know it was quite fast, but anyways, still recorded, and please let me know if you have any more questions so far. Of course, you need to make sure the grid, if you make this too big, it's growing exponentially in terms of computing time. Yes, you can also parallelize over multiple CPUs, but this only grows linearly. So you really need to make sure that you don't you don't make your grid too big, because this just won't be even feasible for the most potent, the biggest computer in the world. And most of the time, it also isn't really necessary to have it fitted to such dense degree. So it's most of the time just important to just be in the right area or in some sweet spot of the model. So you see here, it's just processing through each and every fold. So you also immediately see that the more folds you're using, if you like to use a 10-fold cross-validation, which is standard in most textbooks, this even increases your tuning time even more. So I'm actually a fan of not so many folds. So 5 folds is already most of the time my preferred setting here. So it's close to being completed now.
Is it complicated to do the parallel processing?
No, it's not. Actually, you just need to, no. Okay, not good. No, it's not. For parallel processing, wait a sec. It's requiring the for each package, and with the for each package, you need to maybe we also have something here. So you see the for each package is used for parallel processing. So you would need to load the for each package. And then you need to register your cluster. I'll just check here. I forgot. But basically for each, you need to just register the cluster you're having, or if it's just your local laptop, just the number of cores you want to use. And then it should already be taken care of. Yeah, I can. Unfortunately, the code is not here. I give this hint to you just after the session. Unfortunately, I don't find it now, but the main thing is it's using the for each package in the backend, and you need to register then the number of cores you want to use before, and then you can you use the code as here stated. So it's not taking so much effort, but I unfortunately don't find it here right now. Yeah, this one. So, but include which uses our parallel package. So you need to use the parallel package here and register. But include which uses. Must be the parallel package. Each parallel package such as region. Okay. So the register due parallel function I'm not finding. Okay, not here. So unfortunately, I just give you the right code just after the session.
Okay.
The main thing here is to again, I'm letting this run. Maybe I can now use the time to just grid. It's not really showing. So this example is actually using do parallel, so a different library. So not for each. I just have this from some tidymodels issue, but maybe this is already. So most of them are using actually the do parallel package. Create a cluster. And then register. So the cluster is being created here, in this case, for 4 cores. And then it's just registering. Or here, maybe it's even better. You can also detect your cores, and then you register all the cores you're having. Maybe even better. So it's using do parallel, not for each, in most examples I'm seeing right now. But it's just strange that for each package, but here it will be system, but include do parallel, which is ours built-in parallel package. So in the backend, so what I still don't really get with tidymodels is it's in the backend, it's using the parallel package, but it's still using those kinds of wrappers like do parallel and for each around. But I think this should be some working example. Of course, it needs to be tried out. Yeah. So this worked, fortunately. Now created for each split one matrix or this kind of nested data frame. I'm just checking here for the question, the do parallel package. So all cores. So I'm having this MacBook Pro. It seems to have 8 cores. So let's see if this is doing something. I'm registering the cores. I'm just checking here again the function. The problem is here just that I think that for parallel processing, we don't get the output now. How is it called in Mac? Activity monitor, right? So Zoom is using lots of let's see. Okay, but I don't really see CPU. Percent CPU. It's actually Zoom is using most. I'm not sure if this worked now, to be honest. But
to be completed your command already.
Sorry?
If the command is completed already, you can't you can't see it in the monitoring.
Yeah, that's true. Very good point. So if it was really that fast, then it seemed to work. I mean, of course, I can try it again, but is it doing something? Here you see it, right?
Yeah.
I don't know if you see this, but it seems to have created those R processes. So it's now really computing on multiple cores. For some reason, it's only 5. It's okay. For some reason, the others are already finished. Okay, but this seems,
Maybe it's because you ask only for 5 folds.
that's true. It's parallelizing over 5 folds. But this can also be set somewhere where you can also parallelize on the different parameter sets. Maybe that's the reason. So there is also some option, I don't remember right now, but there is an option where I can parallelize over all different parameters as well. So this might be better if you have more cores here. Okay, but this seems to work. I just let this here. Okay, finally, what we can do is we can collect the metrics. So this is now showing us the best models available, or the results from this optimization. So for each mtry and tree setting, we see here the mean squared error. In this case, we can also have more metrics, of course. There's also this kind of, I think there's also this kind of autoplot function, which you can use here, which doesn't tell me too much. Maybe for the, yeah, try. Okay. Last but not least, what we would like to do is now we would like to finalize our fit. So we would now like to take the workflow. So we take the workflow and we would like to finalize it now. So finalizing means we select the best model. So we select the best model from this tuning setting from XGTune. So the best model seems to be mtry5 with 2000 trees. So that's the result of our tuning. And now we would like to finalize the workflow with our best selected model. And we would like to fit now the model based on our entire data set. Of course, if you would like to evaluate multiple different models, it would make sense to do this kind of evaluation on the test data set we have still. But now, just for the sake of, since time is already running, we're just fitting now this best parameter setting on the entire data set here. So this is now our XG fit. So this is now just taking the best parameters and fitting a new model, a new XGBoost model on the entire listings data set. And so this fit, since it's a workflow, it's not only doing the prediction, so it's not only doing the model prediction, but it's also doing the whole pre-processing, which is stated here in recipes. So this is just important to know. It's not like a vanilla R model you're having here, but it's actually workflow, which combines the recipe and the model at the same time. And this can then be easily saved, XGFit. So using, for example, an RDS file, we can use XGFit and save it here as an XGFit RDS model. So this is the result of our whole tuning procedure, and this model can then be used like any other R model using the predict function. You can use the XGFit model on some new data set, which can be, for example, some random, I don't know, some random listing here. So this is now doing really the price prediction of some apartment. What you could also do is you could do some kind of in-sample fit. So you just predict everything here and bind it back to the listings data set. And for example, create a Ggplot, which basically plots now the price against the prediction. So this shows now the actual, so this is on the x-axis, we have now the price, and on the y-axis, the prediction of the model. We can also just add here a GM smooth. But this shows now how the model performs overall for these kinds of, for those prices. This just doesn't work. Okay, it doesn't work because we need to. Yeah, so this is now also doing some kind of smoothing to see if there's some areas. So for the higher prices, it seems to be a bit off, but altogether the fits seems to be quite okay. So no larger outliers or other issues. So maybe alpha. Just don't see too much. Yeah, it's many listings here. Okay, so this is now the model we've just created. And since time is already running by, I will, of course, share this code with you. You can also post it to the chat, but I will also make it available on GitHub as soon as possible.
I don't know what happens, but I don't see anything that you have pasted into the chat since the beginning of the session.
Not
anything.
I'm so sorry. I just posted everything to panelists and not to panelists and attendees. That is my fault. I just post over again everything. I'm sorry. And okay, then I will also share now the file AirBnB DSC. So I've now also shared the file with you. And in any case, I will also make this available on GitHub. Sorry for that. I just didn't notice that.
That's okay.
It didn't work. Okay. Okay. Just to wrap it up, what we've created so far is quite quickly a model using downloading data from inside BNB, doing some basic pre-processing. We splitted up the data. We created some pre-processing recipe just to put the data in the right form and so that the model can make most use out of it. We created this XGBoost model, this workflow, tuned the model, even using parallel processing. And finally, we stored the model and can now use it as a predictive model for Airbnb. So you could already think of maybe some service, or if you're searching for Airbnb apartments, maybe it helps you to determine if some apartment is cheap or not. And so finally, what I would like to show is what I would like to show here is this kind of workspaces we have here. So you can explore all different kinds of workspaces. And here we also have this kind of Airbnb example to show the undervalued or underpriced Airbnb apartments. in Vienna. So what it's doing is it's really using this kind of XGBoost workflow or model. It's using this model to predict the prices and to calculate a discount from this price. So if the listed price is 100 and the model predicts 50, the discount is 50 minus 50. And so what it's also doing is it's plotting here. So it's doing this. So it's calculating the discount, and based on the discount, it's selecting the 500, in this case, the 500 most underpriced apartments in Vienna. So it's selecting only these apartments and then showing the apartments based on the geolocations on the map. So, for example, you can dive in through this map here, through this leaflet plot, just to determine where are the most undervalued or discounted apartments. So we have here, for example, a nice 2-room apartment in August. It's priced at $11 US, and the model prediction is $55.9 US. So the discount is pretty heavy with minus 80%. So let's see how this looks like. So this is the apartment, all from the data set, of course. And you can just check if this makes sense or just tune the model maybe a bit more. But it just gives you a nice overview where are the most discounted apartments. And it's already making use of this model in the sense that it's, you know, determining here the discounts. And of course, as I've said at the very beginning, everything you have here is also available through the API. So for example, you could also just use the API here, head over and instead of sourcing the entire file, you could also run just the code, just for example, get the most for example, you could also just run the function here just to get the most 10 undervalued apartments. And this is exactly the same as you would do in the editor. So this is actually cool that you can easily just switch from the editor to an API and just have it, if you want, integrated in some other service which doesn't understand any R, but which might be something like a web service or so. So this call I just did here, or with run, you can also do via the API, and I'm just showing you here the output. So this output now shows you, based on the code we just entered the code to evaluate the function to give us the 10 most underpriced apartments. So it's showing here really heavily discounted apartments, minus 70, minus 80%. Just don't take it too seriously. It's all discounted for a reason, maybe. So it doesn't have to be that it's the true price, but this actually looks quite nice. Yeah, so you can play around and see if you're satisfied with the model or if it makes sense. So this maybe is not so nice. Yeah, but maybe you like to play around a bit with it. And speaking of discounts, we can also, as I said, offer, if you send the email to courses@Quantargo, we can offer you a free 3-month developer account. And if you just hit me via email, we also have still free slots for some workshops. So if that's interesting to you, please get in contact. And I'm happy to hear your feedback or your questions, maybe. Not sure. Is there something you would like to ask or talk about?
the 3 months, is it possible to make them start not immediately, but a bit delayed?
Yes, of course. Just send me an email and send me the date when it should be available, or until what date, starting from that.
Okay.
If that works for you.
Yes, thanks.
So great.